one of the most famous thought experiments in physics. It involved a cat inside a box, but here's the twist. The cat was not just alive or dead, it was somehow both at the same time. Sounds strange, right? In this video, we explore Schrödinger cat and how it helps us understand one of the deepest puzzles in quantum mechanics. Quantum mechanics is the branch of physics that deals with particles at the atomic and subatomic level. At this scale, nature behaves very differently from what we're used to in everyday life. Particles don't just sit in one place or follow one path. They can exist in multiple states at once. This strange behavior is called superposition. A quantum object, like an electron, can be in a combination of all its possible states, and we describe this using something called a wave function, a mathematical tool that gives the probabilities of all outcomes. But once we measure the system, this wave function collapses into just one result. This leads to what we call the measurement problem. When exactly does the wave function collapse? And why? Does the act of measurement really decide the outcome? Or does something else cause reality to choose? To highlight this problem, Schrödinger proposed a thought experiment. Imagine a sealed box containing a cat, a radioactive atom, a Geiger counter, a hammer, and a vial of poison. If the atom decays, the detector triggers the hammers, releasing the poison, and the cat dies. But if the atom doesn't decay, nothing happens and the cat lives. Here's where it gets weird. According to quantum mechanics, until we open the box, the atom exists in a superposition, both decayed and not decayed. So, the cat is both alive and dead at the same time. It's only when we open the box that is when we observe the outcome becomes real. But Schrödinger didn't believe in zombie cats. He was actually criticizing the comprehension interpretations of quantum mechanics. His point was, if our theory says a cat can be alive and dead at once, then maybe there's something incomplete about how we understand observations and reality.
In everyday life, things either happen or they don't. But in quantum mechanics, a system can exist in all possible states at the same time. This is called superposition. Schrödinger illustrates this with a famous thought experiment. He imagined a cat inside a sealed box where a quantum event like radioactive decay determines whether the cat lives or dies. Before we open the box, we can't say the cat is just alive or dead. Instead, quantum theory says it's in both states at once until we observe it. Mathematically, we write this using the quantum wave function. It looks like this: psi equals 1 over the square root of 2 multiplied by the state alive plus the state dead. This equation means the cat has a 50% chance of being alive and 50% chance of being dead, but only after we look. This isn't just uncertainty or guessing. In quantum mechanics, all outcomes are real, coexisting in a single wave function until the moment we observe the system. So, what happens the moment we open the box? Before this point, the wave function contains all possible outcomes at the same time. The cat exists in a quantum superposition where it is both alive and dead. No outcome has been chosen yet because we have not observed it. But the moment we observe, something fundamental changes. Opening the box causes the wave function to collapse. The act of measurement forces the system to resolve into one definite state. It is no longer a mixture of possibilities. It is now one specific outcome. Mathematically, this collapse is written as psi collapses into either cat alive or cat dead. This is is not a physical disruption. Instead, it is a change in the information we have. We have moved from a cloud of probabilities to a clear and definite result. Just like drawing a card from a shuffle deck. Once you see it, it becomes real. You can no longer return to the unknown. Quantum mechanics isn't just a theory, it's becoming real technology. Superposition and collapse are the driving forces behind some of the most powerful innovation today. In quantum computing, a qubit can exist in multiple states simultaneously. This means a quantum processor can try many solutions at once, and when we measure it, collapses gives the final answer. Quantum cryptography uses this collapse to ensure privacy. If anyone tries to intercept the quantum key, the act of observation collapses the state and alerts both sender and receiver. This technology is already being used to protect sensitive information between satellites. And even nature may already be quantum. In photosynthesis, energy seems to flow through all possible paths at once using superpositions. And birds might actually see Earth's magnetic field using quantum coherence in their eyes. These are no longer science fiction. Superposition and collapse are shaping the future of science, security, and life itself.
Even today, Schrödinger cat is used to illustrate how quantum principles like superposition and measurements are still debated. It reminds us that quantum mechanics is not just about equation, but about what reality really means. And yes, it's still one of the strangest, coolest thought experiments in science. So, is the cat dead or alive? Maybe both, or maybe the universe is a lot weirder than we think. Thank you.